In this video, we're going to be talking about population variance. You'll notice I'm using the word population. That's because we can find variance for a population when we know all the members of a population. But later on, we're going to be finding variance of a sample. So these are going to be different formulas, one for population and one for sample, but both finding what we're going to be calling variance, which is our second measure of dispersion. So we're going to define what is population variance. I'm going to show you the formula for variance, and we're going to go through the steps of calculating variance. This is probably one of the most important learnings in this class. So you want to make sure that this is a video that you really do take in well. So variance is preferred to range because it includes all of the scores in the distribution. And what it does, it describes the spread of the scores from the mean. And it really is the average of what we're going to call the squared deviations. Now that word squared deviations might not make sense right now, but we're going to talk about just what that is. So variance is an average of how far each score is from the mean. So think of that. Each score has a distance from the mean, and the variance is the average of those distances. So calculating variance requires several steps, beginning with something called the sum of squares. You're probably going to want to write this down, sum of squares. And it's also known as the sum of squared deviations. Again, that's the sum of squared deviations. So we have two formulas for this sum of squares or sum of squared deviations. Here's the first one. What is it asking you to do? Well, we're going to start in parentheses, and it's asking us to take each score and subtract the mean from the score. Okay, we can do that. This is what we're going to be calling a deviation score. The next thing, according to Piedmont's, is to raise it to the second power or square it. So we'll do that, and then we're going to add up all those squared deviations. And that is what we call the definitional formula. This is the formula that we're going to use for the most part in this class. But later on in the class, you're going to need to know this other formula called the computational formula. So make sure that you are aware of what this formula is asking as well. Maybe play with it a little bit too. But for this lesson, we're going to be really talking about the definitional formula. So what is the computational formula asking you to do? Well, let's start with what's in parentheses. Add up all the scores, square them, divide them by the total n, and then complete the rest of the equation, take the squared scores, sum them up, and so on. But we're not doing this right now. I'm going to show you this in the tutorial video at the end when I'm showing computations. Okay, both formulas will give you the same number, so they are equivalent. They're exactly the same formula, and we'll demonstrate that in the last video. So this is the formula for sums of squares, and you'll notice that we denote sums of squares with SS, capital SS. So there you go. The first thing that we're going to do to be able to figure this out is we're going to need to know the mean, right? So the first step in finding the mean is calculating the sum of all of the scores first, and that will help us to calculate the mean, taking the sum of the scores and dividing it by the total number of scores, right? That's review. And to find the sum of squares, we're going to first subtract the mean from each score. We're going to call this a deviation score. I know this is kind of repetitive. We're going to square those deviation scores, and then we're going to add them up. So it's simple. It's not hard. We can do this. So when I'm getting ready to calculate sums of squares, I often set up a table something like this. So these are the scores from the group A data from the last video. Here they are listed, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are individual scores. If you'll remember from group A, there was one of each score, so that's why it looks this way. If I were to find the mean of these scores, I would first have to find the sum of those scores, and I just did that. So if I add up all of these scores, it totals 54. And I know that there are 9 scores total, which gives me a mean of 6. So I know that when I'm taking each score and subtracting the mean, it's 6 that I'm going to be using in this subtraction. So I've done it here. Here we go. 2 minus 6, 3 minus 6, 4 minus 6, etc. And here are the deviation scores from these subtractions. So you might not even need this column right here. You might be able to just kind of do it in your head. 2 minus 6 is -4, 3 minus 6 is -3, etc. All right, so the next step according to our sums of squares formula is then to take these deviation scores and square them. So that's what we're going to do next. All right, I've done that. So what happens when you multiply a negative by itself? Negative times a negative. That will give us a positive value, right? What happens when you multiply a positive number by itself? Well, that's going to be a positive value too. The reason why I stop and tell you this is that when we add all these numbers up to come up with the sums of squares, it can only be a positive number. You can never have negative sums of squares because you've wiped out the negatives when you square them. So the sums of squares are always going to be positive. So I've squared the deviations and now I'm going to add them up. And if you add all these numbers, you get 60. So right now, my sum of squared deviations is 60. That's going to be helpful for me when I'm calculating variance. So variance means take those sums of squares and divide it by the total number of those deviations, or the total n. And what this will do is it will represent the average of those squared deviations, right? Because when we take the total of values and we divide it by the number of values, that gives us the mean. So when we take the total of the squared deviations and we divide it by the total number, that will mean the mean of the squared deviations, the average squared deviations. And this is the formula that we're going to be using, right? The formula and the symbol that we're going to be using for population variance. Again, we're only talking about populations, not samples right now. So it's the lowercase sigma with squared, basically. So if we take the sums of squares, we divide it by n, we get variance. And this is the symbol for variance. You might want to write down the symbol, write the word variance next to it, and really try to commit it to memory that when you see this, this means variance. And what is variance? It's the average squared deviations, or the sum of the mean of the squared deviations. So if I were to do just that, take the total sums of squares, divide it by the n of the deviations, how many deviations there are, we end up with an average squared deviations of 6.67. 6.67. Okay, let's do some learning checks real quick. In a population of n of 10 with a mean of 20 and an x-score of 30, what is the deviation score? Now, how do we do deviation scores? Think about that. We take the score of 30, we minus the mean, and we end up with a deviation score of a positive 10. Now, deviation scores can be positive or negative. Once we square them, we get rid of that. But the deviations themselves can be positive or negative. So, because some scores are above the mean and some scores are below the mean. So here we go. If we have n of 8 with a mean of 12 and a score of 8, what is the deviation score? Well, what are we going to subtract here to find the deviation score? We take our score of 8, we minus the mean of 12, and here's an example where we have a negative score. A -4 is our deviation score. Think of deviation as how much it deviates from the mean, and in which direction does it deviate? We can tell with the minus or the plus sign. We'll wipe that out when we square it later, but this is the deviation score. One more. In a population of n of 8 with a mean of 12 and a score of 8, what is the squared deviation score? So not just what the deviation score is, but what is the squared score? Well, let's take a look. So we have a deviation of -4, because if you take a score of 8 and you subtract 12, that gives you -4. If you square it or multiply it by itself, you get a squared deviation score of 16. So we're going to have deviation scores and we're going to have squared deviation scores. All right, now we're going to do this as a learning check for Group B. What I'd like you to do is write these numbers down on a piece of paper and write down the symbols on the right because this will tell us exactly what we need to do to find our variance for this population of scores. Pause the computer and then come back. So here we have everything we need to be able to find variance for this set of scores. And so what I'm going to do first is I need to find the mean of these scores. And in order to find the mean, that I have to sum them all up first. So I have 10 plus 7 is 17, 24, 30, plus 6 is 36, 42, 52, 54. So my total number of the values of the scores is 54. Now I need to know how many scores there are to find the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my n is 9. So my mean is 9, or 54 divided by 9, which gives me 6. So I know I'm going to be subtracting 6 from all of these numbers to find the deviation scores. I want to find how much these scores deviate from that mean of 6. So 2 minus 6 is negative 4. 5 minus 6 is negative 1. 5 minus 6 is negative 1. 6 minus 6 is 0, and 0, and 0. 7 minus 6 is 1. 7 minus 6 is 1. 10 minus 6 is 4. So what I have here again, these are the deviation scores. Now I need to square them. Now I will just say this. You might be thinking, why don't we just average these scores to find the average deviation? Well, let's add up these scores first, because when you're averaging, you have to add the scores before you divide by the total n. Negative 4 plus negative 1 is negative 5. Negative 6 plus 1 is negative 5. Plus 1 is negative 4. Plus 4 is 0. So if you were to add your deviation scores, they add up to 0. So we can't find an average of them. That's why we're doing these squared deviations, to get rid of these negative signs. So here we go. Now the next step is to take the score minus the mean, the deviation score, and square it. So negative 4 times negative 4 is 16. And 1, and 1, and 0, 0, 0. 1 times 1 is 1, 1 times 1 is 1, and then 4 times 4 is 16. So now I need my sum of squares. I need the sum of the squared deviations. So 16 plus 1 is 17, plus 1 is 18, 19, 20, plus 16 is 36. So I know that my sums of squares are 36. And if you'll recall for variance, it's the sums of squares, I'm going to write it up here, divided by the n. So I'm going to take 36 and divide it by n, and that gives me a variance of 4. So the variance, the average squared deviations of these scores is 4. Let's see what this looks like as a graph. All right, let's take a look and see what this looks like comparing our graphs with our calculated variance formulas. So we have for group A 6.67. That was the variance we found in the first group. And the variance for this last group we just did was 4. So what does that mean? Well, 4 is less than 6.67. That means that group B has less variance than group A. And you can just see that. In group A, the scores are very spread about. But in group B, the scores are more tightly clustered in the center. You have a couple on the outside, but it has less variance. There's more similarity in these scores than there is in this score, in this group. So less variance, less calculated variance means that the scores are more tightly clustered together. Greater variance means that they're more spread apart. Okay, in the next video, we're going to be talking about population standard deviation. And this is the last of the 3 measures of dispersion that we're talking about, and then we're going to talk a little bit more in the videos that follow. But the 3 measures, again, were range, variance, and standard deviation. And again, so far we've only been talking about populations. Later on, we're going to talk about samples. I'll see you at the next video.